Okay, so in this question it says, in a partially destroyed laboratory record of an analysis of a correlation data, the following results only are available. Okay, so what we have is variance is given. Variance of x is equal to 9. Now we know that variance of x means when you square the standard deviation of x, we will get the variance. So this is what we have. Then you also are given with the regression equation, line of regression equation, which is 8x minus 10y plus 66 equals to 0, and the other line is 40x minus 18y equals to 214. Now we are not sure which one belongs to x on y or y on x, so like probably let's try to make x or y subject from any of the given equation. So let's take, since 10 is bigger than 8, I'll try to make y on x from this first equation. So which means I'll be getting negative 8x minus 66. So taking the terms to the other side, then dividing the whole thing with negative 10 to remove the coefficients. So I have y equals to 8. So since this is having common factor, that's 2, so 2 times 4 is 8, 2 times 5 is 10, so negative will be positive. So you have 4 over 5x plus 2, 3 is 6, 2, 3 is 6, 2, 5 is 10, so you have 33 over 5. Now this is y on x, regression line of y on x. Then this, from here I should take x on y, meaning x should be subject. So 40x, rest everything to the other side, then divided by the coefficient, that's 40. Then I'll have x equals to, since both has the factor for 2, so 220, 1, 2, 7 is 14. Then you have 220, 9, 18, so 107 over 20 plus 9 over 20 y. So this is your regression line of x on y. Now so these are the only information given, right? So question 1 says the mean value of x and y. Now since we already know that mean, which is represented by x bar and y bar, are also the intercepts, So intercepts means they are common between two equations, right? Common in both the equation. So which means I need to find the common x and y from these two equations. So what I will do is let this be equation 1 and the other be equation 2. So substituting equation 1 in 2, so you have x equals to 107 over 20 plus 9 over 20 times, so I'm replacing y with the value here, so 4 over 5x plus 33 over 5. So I have x equals to 107 over 20 plus multiplying numerator, so 9, 4, 36, 5, 2 is, so 50 into 2 is 20, is 100, 5 into 20 is 100. Then I have x, then I need to multiply here, so 9, 3, 27, 9, 2, 27, 28, 29. Then you have 100. Okay, then bringing in, shifting like terms together, then 107 over 20 plus 297 over 100, trying to make same denominator, So multiply 5. Okay, so I have 100x minus 36x over 100 equals to 5735 plus 297 over 100. So 100 cancel. So I have here 100 minus 36 is 4, so 64. So yeah, 64x equals to, so 2 1 10 13 7 8. Then dividing 64 on both sides to get the value of x. So let's try to, the common factor seems to be 8. 8 8 64, 8 1 is 8, and 8 4 is 32. Then you have, can I do with 8? Yes, 8 1 is 8. Here 8 1 is 8. 8 3 is 24. So your x seems to be 13. So using this value in equation 1, so I have y equals to 4 over 5x plus 33 over 5. So your y equals to, replace the value of x, which is 13. Then I have plus 33 over 5. So y equals to 4 3 is 12, 4 1 is 52 plus 33 over 5. So y is equal to 85 over 5, which is equal to 17. So you have your x bar as 13 and y bar as 17. So these are mean. Now part 2 says regression coefficient. So regression coefficient here means bxy and byx. Now since you know that, since your regression coefficient is byx and bxy, and they are slope, that is why from the two equation here, okay, so I got the first equation and taking the second equation. Okay, so the coefficient is your bxy. Since your coefficient is your bx, the regression coefficient, so this is y on x, so the coefficient of the variable here is 4 over 5, and in your x on y, the coefficient is 9 over 20. So these are regression coefficient. Then you have part 3 says standard deviation of y. So since we know that, so if you have to find standard deviation of y, so the third question is find standard deviation of y. Now what we know is there is a formula where b y yx bxy or byx. So since this is standard deviation of y, I can keep as bxy is equal to, you have r times standard deviation of x over standard deviation of y. So if I make standard deviation of y as subject, shifting to the other side, it will come in the numerator's place, and I just have to multiply r times standard deviation of x over bxy. Now why I'm doing this, because we already have the value of bxy. To find your r, it's easy, square root of bxy times byx, and we already have the value of the coefficient regression. So after putting this in, so 4 1 is 4, 4 5 20, so r is equal to 3 over 5, and we got the value of r. So now there's also the presence of r. Now standard deviation of x, if you check on in the beginning we got the value of variance. So here if I square root on both sides, I'll be getting standard deviation of x equals to 3. So which means you have the value of standard deviation of x as well. So this leads us to get, okay, 3 over 5 times you have 3 over 3 divided by, so bxy, value of bxy, x on y is 9 over 20. So standard division of y equals 2. So 3 times 3 is 9. 9 over 5. Changing division would to multiplication, it will be, you have to reciprocal here. So 4 5 1 is 5, 5 5 20. So you have, therefore your standard division of y is equal to 4. Now coefficient of correlation between x and y, that's what we already have found. So this is 3 over 5. Yeah, this is question 4. So basically we found out the answer.